Hello friends, you're welcome once again to another fascinating math video. Now in this video, we're considering solving problem from analysis, in particular the real analysis. As I used to say in my previous videos, I shall not be considering a detailed explanation on concepts because in doing so, we shall waste too much time because explaining in detail usually takes time and it will make the video to be too lengthy. All right. Instead, we are focusing on solving past questions. Now, I would like to also inform you that I offer personal, private online math tutoring service. So if you're interested in a private online math tutoring service, be very free to get across to me because I'm very competent when it comes to mathematics. I studied mathematics to the university level and I've been in it for over a decade, teaching different levels, primary, secondary, the college, and so on like that. All right, so I'm very competent when it comes to mathematics. You can also click the link, the Facebook link, to see the previous video I've done. All right, there are other videos I've done on maths that may interest you. So let's get over to solving this particular problem. Now we are to evaluate this sum. This is an example of a telescoping series. Now, what is a telescoping series? Before that, it may not appear as a telescoping series because of the radical sign. All right. So we tried as much as possible to reduce it to a telescoping series, which I will soon define. Now, when you are given a problem of this sort, what you try to do, you try to simplify the radicand in such a way that it become a power so that it reduces to a polynomial in some expression. All right. We reduce the radicand in such a way that it's transformable into a polynomial in some expression. So let's go about carrying out this. And in order to carry out this, we should observe that the identity alpha squared plus beta squared. Okay, let me write this first. Solution. Now observe that alpha squared plus beta squared is equal to writing alpha plus minus beta all squared, the minus that is minus plus 2 alpha beta. This result is very useful in simplifying the radicand. All right, very useful. Now take note, how do we interpret this? This value you are seeing, that is, we mean alpha squared plus beta squared is equal to writing alpha plus beta all squared minus 2 alpha beta, or, and this is also equals to writing alpha minus beta all squared plus 2 alpha beta. Whichever you take is correct. All right. So with this identity, we were able to reduce that radicand into a power, a stable power. All right. Now observe that. Observe that 1 plus 1 over n plus 1 all squared, or plus 1 over n plus 2 all squared can be written as 1 squared. I can put coiling bracket here, plus 1 over n plus 1 all squared. All right, close this. Then plus 1 over n plus 2 all squared. We can write this in this form. So in this way, looking at this particular expression over here, let me illustrate. This expression. Can you see this expression? Looking at this expression, it resembles the expression you are seeing here. Look at it. Can you see that? But in this case, your alpha is 1 and your beta is 1 over n plus 1. So using the transformation, using this first transformation, this. Can you see that? So in place of alpha, we put 1, and in place of beta, we put 1 over n plus 1. So using that transformation, we have the following. This is equals to writing. Now we are not transforming this alone. All right, this over here. So we have it as 1 plus 1 over n plus 1 all squared minus 2 over n plus 1. So we're done with transforming this particular expression. Then we can add up this next term. Now, taking the first and last term, we have once again, okay, first of all, let's simplify the first term. So on simplifying the first term, we have our result as n plus 2 over n plus 1, all squared. Can you see that? Minus 2 over n plus 1 plus 1 over n plus 2, all squared. Now, taking the first term and the last term, then we have n plus 2 over n plus 1, all squared, plus 1 over n plus 2, all squared, then minus 2 over n plus 1. All right, now looking at this expression once again, that is this expression here, you seen that? It resembles this you've seen here. Exactly what you're seeing here. But in this case, alpha, my alpha is considered as n plus 2 over n plus 1, while my beta is considered as 1 over n plus 2. So on taking this identity, I mean this second result, expressing it in terms of this second result, we shall have a very beautiful form. Now, if you use this first result, the radicand cannot simplify. When you use this second result, the radicand will simplify. All right, so let's go over to simplify the radicand. So in this case, we have our result as, let me put a square bracket. We have n plus 2 over n plus 1 minus, can you see that? 1 over n plus 2, then all into square. Since this is minus, from our result, here will be plus 2 multiplying each term. Can you see that? Then minus 2 over n plus 1. From whence we have our result to be equals to, we can now put a curved bracket, n plus 2 over n plus 1 minus 1 over n plus 2, all squared, plus, now this we divide out with this, we're left with 2 over n plus 1, and that will cancel out with this last term over here. So on cancellation, we are left with a square, which is the power, the second power. All right? Can you see that? All squared, right? So this is what we are looking for. Once again, the term within the parentheses, the first term within the parentheses can be written as, this term, let me illustrate. This term over here, can you see this term? This term you see over here can be written as 1 plus 1 over n plus 1, all right? So instead of, we'll come over to our original problem. Instead of this expression here, this expression, instead of this expression over here, we shall be using our simplified results, all right? So I can now come and say, therefore, the sum from n equal to 1 to 998 of this expression, which is 1 plus 1 over n plus 1 squared plus 1 over n plus 2 squared. This cannot be written as the sum from n to 1 running to 998 of the square root of brackets 1 plus 1 over n plus 1 minus 1 over n plus 2, all squared, all right? So we have this as a result. Let me take more page because our page is exhausted. All right. Now, this is equals to now writing the sum from n equal to 1 to 998. We now have 1 plus 1 over n plus 1 plus 1 over n plus 2 as the result. So taking individual sums, we have it as 1 plus sum of 1 over n plus 1 ranging from n equals 1 to 998, Please, there's a mistake. I think we made a mistake. Here is minus, it's not plus. So minus is here, all right? So that means I have it as minus. The sum of from n equals to 1 to 998 of 1 over n plus 2. So the work is done from here. Now, this is an example of a telescoping series. I mean this series over here. Let me illustrate. See this series over here? It is an example of a telescoping series. Now, what is a telescoping series? Now, a telescoping series are series where most of the terms cancel out, leaving us only a few terms. So when you observe that most of the term will cancel out and a few terms will be remaining, such a series is called telescoping, as the name implies, telescoping series. All right. So in this scenario, the first term here, I mean this first term, the result of this means you're adding 1 until you get to 999. So in that case, our result for it become 998, all right, a plus. Now let us express this one in a series form. So on expressing it in a series form, we have our result as 1 over 2. That is when n is 1, you have 1 over 2 plus 1 over 3 plus. You keep on going until n we assume 998. And when n assume 998, we'll be having 1 over 999. All right. So we're done. So this one you see here is for this. Take note of that. All right. Then minus the same logic you apply. So when n is 1, we'll be having 1 over 3 plus 1 over 4. It keep on going until it gets to when n assume 998. The result will be 1 over 1000. Can you see that? Now, if you observe carefully, you see that terms will cancel out. So on expansion, we shall have our result as 998 plus. Okay, let me remove the brackets now. We now have 1 over 2 plus 1 over 3 plus dot 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 as the ellipsis over 1 over 999 minus we have 1 over 3 plus 1 over 4 plus you eventually get to 1 over 999. Sorry, there's no need to be plus because the minus will expand in. So we'll be having minus 1 over 4 minus until you get to minus 1 over 999. Then lastly, minus 1 over 1000. Can you see that? Now you see that all these terms we cancel out. I mean, these terms you see here, we cancel out with these terms. So we're left with 1 over 2 minus 1 over 1000. In that case, the results telescope to 998 plus 1 over 2 minus 1 over 1000. All right, so we have this as a result. So it is very easy to do from here. This can be written as 998 plus, now this 1 over 2 can be written as 500 over 1000, all right, minus 1 over 1000. Therefore, once we have our results to be 998 plus 499 over 1000. Can you see that? Then we can write this as a mixed number as 998 499 over 1000. And this is the result. That is the sum. So we can therefore boldly say that therefore the sum from n equals 1 to 998 of this expression 1 plus 1 over n plus 1 squared plus 1 over n plus 2 squared. This sum is found to be 998, a whole number 499 over 1000. All right, so this is the sum. So you take a good once, twice, and thrice for proper grasp of what I've discussed. So if it's not clear to you, are very free to comment and I will get across to you. So don't forget that I render exclusive online math tutoring service. So if you're interested in my service, be very free to get across to me via my email or you click the link that will take you to my Telegram where we can discuss in detail regarding how the class will be. All right. So thank you very much for paying attention. Till another time.